Imagine sitting in a sterile clinic room. The doctor walks in, they're holding a printout of your latest blood panel, and they point to a set of numbers that just instantly trigger clinical panic.
Right, the classic red flags.
Exactly. So your blood sugar is sky high, and there's a heavy, just undeniable presence of acetone.
Which is what we usually refer to as ketones.
Yeah, exactly. Ketones, flooding your blood, spilling over into your urine. And for decades, the standard medical reflex to that specific combination is to treat it as a catastrophic failure of the human machine.
I mean, it's the ultimate red flag in modern endocrinology. We are totally trained to view those elevated numbers as the disease itself, like a hostile takeover of the bloodstream that just has to be violently suppressed.
But the material we were exploring today for this deep dive flips that entire paradigm on its head.
Completely on its head, yeah.
We are diving into a set of highly unconventional, honestly incredibly controversial notes from a radically different medical perspective. And this source material suggests that those sky-high numbers, the sugar and the acetone, they aren't a sign that your body is failing.
No, not at all.
Yeah.
According to this text, they are a perfectly orchestrated, desperate defense mechanism.
So if I'm understanding the mission of this deep dive correctly, we're going to attempt to decode the body's natural signals through the lens of this alternative framework.
Right.
We'll be looking at the really complex relationship between the endocrine system, the liver, and cellular energy production. Because the goal for you, the listener, is to separate what the source argues are the body's natural life-saving emergency responses from the chronic side effects caused by modern medical interventions.
And I think it's really vital we establish some boundaries right up front before we start dismantling these physiological concepts.
Oh, absolutely.
The text we're analyzing contains intense, unrelenting critiques of standard medical practices. I mean, specifically targeting conventional diabetes treatments, pharmacology, and what the author views as toxic dietary dogmas.
Yeah, it holds nothing back.
It really doesn't. So our role here is just to impartially synthesize this biology and unpack these unorthodox arguments. We're exploring the mechanical claims made by the author to help you understand this specific viewpoint.
Right, we are definitely not endorsing these claims as absolute medical fact, nor are we offering medical advice.
Exactly. We're just looking at the source material.
So let's jump right into the deep end. To understand why the author believes our standard interventions are causing harm, we first have to completely redefine the origin story of sugar and acetone in the human body.
Yeah, we have to look at where it actually comes from.
And the source uses a rather extreme historical analogy to ground this. It asks you to consider states of absolute prolonged starvation or just immense physical stress.
Like the prophet Moses fasting for 40 days on Mount Sinai.
Right. Or bringing it into a more modern physiological context, think of an infantry soldier in the third day of a relentless, exhausting battle. Or maybe an ultramarathoner pushing way past their physical limits.
Well, just totally depleted.
Exactly. If you were to draw blood from Moses on day 39 or that soldier mid-firefight, you are going to find massive concentrations of blood sugar and acetone.
And the author uses that extreme example to establish a fundamental baseline of logic. I mean, neither of those individuals has consumed a single carbohydrate.
Right, there is no food.
There is zero external sugar entering the digestive tract.
Yeah.
Therefore, finding high glucose and acetone in someone undergoing severe starvation or intense physical trauma, well, it cannot logically be classified as a metabolic disease.
Because it's a state of profound struggle.
Yes, exactly. It represents the body's ultimate compensation strategy. It's trying to keep the organism conscious and functioning when the external fuel drops to absolutely zero.
Okay, so if the fuel isn't coming from a meal, we have to look at the internal supply chain. Where are these massive amounts of sugar and acetone actually being manufactured?
The liver. Specifically, the source zeroes in on the hepatic mitochondria.
Right, the famous mitochondria. We always hear them called the powerhouse of the cell.
Yeah, but the text frames them more like a highly elite, off-grid survival factory that's basically running two distinct manufacturing lines.
Okay, break those manufacturing lines down for me.
So the processes are gluconeogenesis, which is the creation of new glucose, and ketogenesis, which produces the acetone.
Okay.
And the paradigm shift the author introduces here is that finding these substances in the blood does not prove your liver is damaged. According to the text, it proves the exact opposite.
Wait, really? It proves it's healthy.
Yes, it proves your hepatic mitochondria are robust, healthy, and doing exactly what they evolved to do. I mean, if your liver were truly failing, the very first clinical sign would be a catastrophic fatal drop in blood sugar.
You would just instantly crash.
You'd be dead within minutes. These manufacturing lines are continuous, independent operations running 24 hours a day.
Okay, let me try to synthesize the raw materials the source says this factory is using because it's honestly a brilliant recycling mechanism.
Oh, it's incredible.
To manufacture the sugar, the liver doesn't just pull from nowhere. It takes pyruvic acid, which is essentially the exhaust from the normal metabolism of your red blood cell.
Right, cellular exhaust.
Yeah. And it takes lactic acid, which your muscles produce when they work. It gathers up odd-chain amino acids, organic acids, and glycerin. It's literally taking the biological trash and upcycling it into premium, life-saving glucose.
And trash might be underselling the biological elegance here.
Fair point.
Because the liver views lactic acid not as a toxic byproduct that causes muscle cramps, but as unrefined metabolic gold.
Wow, unrefined gold.
Yeah, it shuttles that lactate back to the mitochondria and expends energy to reform it into glucose. Now, the acetone production relies on a completely different stockpile.
Right, the fats.
Exactly. The mitochondria harvest even-chain fatty acids from your stored body fat. They break those fats down, synthesize them, and spin out acetone.
The distribution of these two fuels is where the source highlights a very strict division of labor. Like, the glucose that the liver meticulously crafts is hoarded for the most critical systems.
It's VIP only.
Yeah. The brain, the muscles, the lungs, and the red blood cells get exclusive access to the sugar. And the acetone is then exported to feed the rest of the peripheral body.
But, and this is wild, there is a massive paradox here regarding the liver itself.
The chef paradox.
Yes. The liver is the only organ making all this acetone. It's acting as the master chef for the entire body. Yet the text states the liver is the one organ completely incapable of using acetone for its own fuel.
Wait, so it makes all this energy and can't even burn a drop of it?
Not a single drop. It's a brilliant evolutionary failsafe if you think about it. If the liver could metabolize the acetone it creates, it would probably consume the entire supply during states of starvation to fuel its own incredibly high energetic demands.
Oh, so it would just be greedy and starve everything else.
Exactly. So by lacking the specific enzymatic ability to catalyze or burn acetone, the liver is forced to ship it out into the bloodstream. It literally guarantees that the peripheral organs survive.
That is fascinating. But okay, so if this off-grid power plant is constantly churning out sugar and acetone every single hour of the day, it raises an obvious mechanical question.
Why don't we see it on tests?
Yeah. Why doesn't a perfectly healthy person test positive for high acetone when they take a routine lab test?
Well, the absence of detection simply comes down to the speed of consumption versus the speed of delivery. In a robustly healthy individual, the peripheral tissues are burning the acetone the exact second it arrives.
It's just instantly gone.
Exactly. It never has the opportunity to pool in the bloodstream. The text introduces a crucial mechanical concept here regarding why it finally shows up on a test, and it's called interstitial fluid volume.
Okay, so that's the fluid surrounding the cells, right?
Yes. When an individual is under severe physiological stress, or maybe they're just chronically dehydrated, the overall volume of that fluid drops. Blood circulation becomes sluggish, the venous return slows down, and blood basically begins to pool in the lower extremities and the abdominal cavity.
Like the delivery trucks getting stuck in traffic?
That is a really highly functional way to visualize it. Because the blood is pooling, the acetone isn't reaching the tissues that need to burn it, so it just accumulates in the bloodstream, eventually reaching a concentration high enough that it spills over the renal threshold into the urine.
So the liver didn't necessarily malfunction and produce too much?
No, the circulatory delivery system failed. It caused the fuel to just pile up on the loading dock.
Okay, so if the body is deliberately manufacturing the sugar to survive a stressful event, and the acetone is just a byproduct of sluggish circulation, we have to address the massive elephant in the room.
The insulin reflex.
Yes. When the modern medical field sees that spiked blood sugar, the immediate universal reflex is to blame a lack of insulin. Your pancreas is failing. And the source goes completely on the offensive here, dismantling this insulin-only mindset.
Yeah, the author views this fixation on insulin as completely biologically illogical, particularly in fasted or stressed states. The text defines insulin in very rigid terms. It says insulin is an eating hormone.
An eating hormone.
Its entire biological purpose is to respond to the physical active food entering the digestive tract.
So blaming high blood sugar on a lack of insulin when a person hasn't eaten in 12 hours, I mean, that's like blaming a fire alarm for not going off when there isn't a fire.
Right,
The
exactly.
pancreas isn't broken or lazy, it's just off duty because there is zero external food supply to manage.
And that logic holds perfectly within the source's framework. If there is no external food and therefore no physiological reason for insulin to be present, we have to look at what is actively driving the blood sugar so high.
The hormonal symphony.
Yes. The author points to an entire biochemical symphony of systemic hormones. We're looking at cortisol, adrenaline, noradrenaline, growth hormone, thyroid hormones, testosterone, estrogen, and glucagon.
I want to clarify the geography of those hormones based on the text, though, because glucagon is acting locally, right?
Yeah, it's an intestinal hormone operating mostly within the abdominal circulation.
But the others, like the adrenaline, the cortisol, the growth hormone, those are systemic. They are flooding the main bloodstream. And the source argues that every single one of these systemic hormones has a direct line to the liver, basically screaming at it to ramp up the production of sugar and acetone.
And this is where we really have to look at the chain of command. Because these systemic hormones, they don't just spontaneously decide to flood the bloodstream.
They're following orders.
Exactly. They are foot soldiers following orders from a supreme commander. The text delves really deeply into the hypothalamic pituitary axis.
Okay, break that down for us.
So the hypothalamus, which is nestled deep within the brain, is constantly monitoring the body's status. If it detects a drop in blood volume, a severe infection, or absolute starvation, it interprets that as an immediate threat to the brain's survival.
The brain realizes it's suffocating or starving, and it panics.
It communicates that panic directly to the anterior lobe of the pituitary gland via a specialized blood portal. The pituitary then acts as the general, dispatching messenger hormones throughout the body.
So it's sending out the orders.
Right, it commands the thyroid to alter the metabolic rate, it signals the gonads, and most importantly, it screams at the adrenal glands to dump massive, just massive quantities of cortisol and adrenaline into the blood.
Okay, let me stop you there and play the role of the skeptical patient for a second, because the implication of this is terrifying.
It is a huge leap, yeah.
Yep. If I go to the doctor and my blood sugar is 300, the doctor assumes my pancreas is failing and I need insulin. The source is arguing that the doctor is entirely blind to the fact that my brain, the highest biological authority in my body, might be intentionally forcing my adrenal glands to pump out adrenaline to spike my sugar because the brain thinks I'm dying.
The text argues exactly that. It's a fundamental misunderstanding, according to the author. The high blood sugar is not the pathology. The high blood sugar is the life raft.
Wow.
The brain is an obligate glucose consumer in these acute stress states. If blood pressure drops, the brain demands more concentrated fuel to stay conscious. It is triaging the entire organism, literally sacrificing peripheral efficiency just to keep the central processor online.
Which means if a medical professional steps in and chemically shuts down that life raft,
They are actively working against the brain's survival strategy.
that is a heavy pivot into the danger of treating digital numbers over actual physical symptoms. I mean, the source uses a really grim scenario to illustrate the consequences of this. We've all known someone who ends up in the intensive care unit.
Yeah.
And the author paints a picture of an end-stage ICU patient. Their blood pressure is crashing, their kidneys have shut down and completely stopped producing urine, they are functionally dying, and on the monitor, their blood sugar is reading alarmingly high.
Right. And standard protocol in that scenario often dictates administering massive, continuous intravenous doses of insulin to force that glucose number down into a normal range.
Just chasing the number.
Exactly. And the author observes this practice and points out a devastating reality. The insulin does not heal the patient.
It doesn't restart the kidneys.
Yeah.
It doesn't fix the plummeting blood pressure.
It achieves absolutely nothing other than treating the digital readout on the monitor. The underlying physiological crisis, which is the very crisis the brain was trying to fight by raising the blood sugar in the first place, marches on until the patient expires.
The author is fiercely critical of this blind adherence to lowering a number while the biological machinery collapses. And it's not just the extreme ICU cases either, right?
No, it applies to everyday management, too.
Yeah, the text analyzes the everyday diabetic patient who is meticulously taking their prescribed medication. We see these patients ending up hospitalized with severe hypoglycemia.
Massive, dangerous sugar crashes.
Or they're suddenly fainting in the middle of the day. The medication is doing exactly what it was engineered to do. It lowers the sugar, but it does so blindly. If your brain intentionally raised your sugar to keep you conscious because you had, say, poor circulation that day, and the drug aggressively forces the sugar down,
Your brain is instantly starved of fuel. You pass out.
but you're touching on the symptom, right? The root cause of this chronic deterioration, according to the author, lies in a fundamental misunderstanding of cellular mechanics.
Yeah, and the text introduces a highly provocative argument here regarding the HbA1c test.
Okay, the A1C. This is the gold standard metric for diagnosing and managing prediabetes and diabetes. It basically measures the average blood sugar over roughly a 3-month period.
Exactly.
Now, standard physiological doctrine tells us that the cell is like a locked fortress. Glucose is floating outside in the blood, and insulin acts as the exclusive molecular key. Insulin binds to the receptor, unlocks the door, and allows the glucose to enter the cell for energy. The premise is no insulin, no sugar enters the cell.
And the author spots a glaring contradiction in that accepted model. Think about it. The HbA1c test does not measure free-floating sugar in the blood plasma.
Right.
It measures glycated hemoglobin. Hemoglobin is the protein complex locked inside the red blood cell. The laboratory test is literally quantifying the amount of sugar that is physically attached itself to the protein inside the cellular fortress.
Okay, this is the moment in the source material that forces you to just stop and reread.
It really is.
The text asks, if a patient supposedly lacks insulin, and insulin is the absolute non-negotiable key required to open the cellular door, how did all that sugar get inside the red blood cell to permanently bind to the hemoglobin and trigger a high A1C result?
Exactly. The mechanical implication is that the red blood cells, and likely other critical tissues, do not actually require exogenous insulin to absorb glucose during a survival state. The sugar is moving across the membrane through alternative gradients or alternative transporters.
And the source escalates this argument even further. It claims that when you inject artificial insulin into this system, you are not actually helping push sugar into starving cells.
The author argues that the synthetic insulin forcefully pulls the sugar out of the blood and potentially strips it from the very cells that managed to secure it in the first place.
The text labels this phenomenon cellular starvation. By artificially dropping the blood glucose to satisfy a lab metric, you are chronically depriving the most vital tissues of their required energy substrate.
And long-term consequences of this medically induced starvation that are outlined in the text are just terrifying.
Yeah, they really are.
It links this chronic energy deprivation to Alzheimer's disease, basically arguing the brain is slowly, methodically starved over decades. It links it to kidney failure. It details severe muscle stiffness and fibrosis because the muscle tissue literally rigidifies without adequate fuel.
It causes anemia as the red blood cells are drained. You are essentially looking at medically accelerated aging.
The core philosophy here is that modern medicine has become hypnotized by digital readings. We treat the glucose meter, we treat the blood pressure cuff, we treat the lipid panel.
We treat everything but the patient.
Exactly. In our obsession with normalizing the data, we become entirely deaf to the physical human being sitting right there on the exam table.
Right. The patient is sitting there complaining of unrelenting, unquenchable dry mouth. Their vision is blurring. They're experiencing crushing chronic fatigue, lethargy, a rapid, fluttering heartbeat. They feel dizzy every time they stand up.
And the clinical response is often, well, your A1C is down to 6.2, so whatever you're doing, just keep doing it.
It's wild. But the text highlights a very insidious psychological trap that occurs when patients begin insulin therapy. Initially, many patients will actually report feeling significantly better.
Wait, if the insulin is causing cellular starvation and driving muscle fibrosis, how could they possibly feel better?
Well, according to the text, it comes down to the anabolic nature of insulin. It is a fat storage hormone.
Right, okay.
Patients suffering from a chronic metabolic crisis often experience severe weight loss. They look in the mirror and see their bodies wasting away, which triggers immense psychological terror. They believe they are literally disappearing.
That makes sense.
When they begin taking insulin, the hormone forces the body to store fat. The patient gains 10 or 15 pounds. They look in the mirror, see their faces filled out, and the psychological relief is profound.
So the relief is entirely cosmetic. They feel better because they look less sick to themselves, but the underlying mitochondrial crisis is completely untouched.
Exactly untouched. Their mouth is still dry, they're still urinating constantly, their energy is still completely hollow. They are just carrying more adipose tissue while their brain slowly starves.
The body is still desperately trying to signal that it's under threat, but the signals are just being chemically muffled.
Let's shift gears a bit because the source doesn't just focus on the chronically ill. It tackles a demographic that supposedly does everything right.
The gym goers.
Yeah, the people who refuse medication, who meticulously track their macros, who are in the gym 5 days a week. Why are so many of these hyperfit individuals struggling with the exact same chronic fatigue and hormonal collapse?
Oh, this is a fascinating part of the notes. The author dissects what we might call the athlete's illusion. The text spends a considerable amount of time deconstructing the myth of the healthy bodybuilder.
You have individuals with zero body fat, massive musculature, who drink gallons of water and eat purely clean diets. Yet the text claims they are walking metabolic disasters.
The text specifically mentions these athletes suffer from ruined colons, profound chronic exhaustion, and in men, deformed or highly weakened sperm.
I mean, I have to push back on this a little on behalf of the fitness community. The source claims that eating the standard 1 gram of protein per kilo of body weight is what ruins the colon. But humans have eaten high-protein diets for millennia. How does a chicken breast magically destroy the digestive tract?
Well, the text argues that it's the sheer continuous volume of concentrated protein forced into the digestive tract that overwhelms the enzymatic capacity of the stomach and small intestine.
It's just too much all at once.
Exactly. Because it cannot be fully broken down, it enters the colon and undergoes putrefaction. The constant presence of rotting organic matter chronically inflames the mucosal lining of the colon.
Yikes.
But the dietary aspect is really only half of the equation here. The more severe critique involves physical mechanics and posture.
You're talking about the aesthetic obsession with the rigid six-pack.
Yes. The text introduces the really critical concept of intra-abdominal pressure. Individuals who relentlessly train their core to maintain a permanent, rock-hard abdomen, or even women who undergo surgical tummy tucks that pull the abdominal fascia drum tight, they are fundamentally altering the internal physics of their bodies.
Okay, let's visualize this mechanically. Imagine trying to inflate a balloon inside a rigid glass jar. Your lungs are the balloon. Your abdominal cavity is the jar.
That's a great analogy.
Normally, when you take a deep breath, your diaphragm flexes downward, creating a vacuum that pulls air into the lungs. Your belly expands to make room for the descending organs. But if your abdominal wall is a rigid wall of contracted muscle that refuses to yield, that downward kinetic energy of the diaphragm hits a brick wall.
The diaphragm literally cannot descend. Full, deep respiration becomes mechanically impossible. So the body is forced to adapt. The individual begins to heave from their chest. They pant. They utilize the accessory muscles in their neck and shoulders to forcefully expand the rib cage.
We've all seen that guy at the gym. Huge chest, constantly taking these shallow, rapid heaving breaths. But why is chest breathing so catastrophic for the metabolism?
Because it disrupts venous return. Your heart relies on a specific pressure gradient to pull deoxygenated blood up from the lower extremities and the abdominal cavity. When you pant and heave from your chest, you drastically increase the pressure inside your thoracic cavity.
So the chest pressure becomes higher than the abdominal pressure.
Exactly. And blood cannot flow uphill against a high-pressure zone. It is like squeezing a garden hose shut. The inferior vena cava is compressed. Less blood returns to the right atrium of the heart. This drops what cardiologists call preload.
Okay.
If less blood enters the heart, less oxygenated blood is pumped out.
And the very first organ to detect a drop in fresh, oxygenated blood is the brain.
The brain experiences immediate hypoperfusion. It senses it is literally suffocating. And this circles us right back to the hypothalamic pituitary axis we discussed earlier.
The brain hits the panic button.
It hits the panic button hard. It screams at the adrenal glands. Drop everything, release adrenaline, dump cortisol, constrict the blood vessels, and spike the blood sugar to keep me alive.
Wow, this completely explains the hormonal chaos in the gym. This guy is standing in front of the mirror, looking shredded, holding his abs tight. Visually, he is the picture of health. But internally, because he is chest breathing and cutting off blood flow to his brain, his endocrine system thinks he's bleeding out in a ditch.
He is locked in a chronic 24-hour-a-day fight-or-flight response.
The mechanical stress completely overrides the clean diet. The hormones are ruined.
And the text points out a very physical manifestation of this endocrine chaos, gynecomastia. It notes how common it is for these heavily muscled, ultra-fit men to develop enlarged breast tissue, often requiring surgical removal.
Because of the stress hormones?
Yeah. The chronic stress from the restricted breathing and abdominal pressure throws the ratio of testosterone to estrogen completely out of balance.
So if the digital numbers are lying to us, And the standard medications are starving our cells, and even hitting the gym with a six-pack can ruin our hormones and our colons. What exactly is the practical application here?
How do we actually use this information?
Right. How are we supposed to navigate a metabolic crisis? And more importantly, how do we protect these hepatic mitochondria from failing in the first place?
Well, the final sections of the source material pivot from theoretical physiology to highly practical, non-digital crisis management. The author provides actionable steps that rely entirely on understanding physical mechanics rather than chasing lab numbers.
Let's walk through the fainting scenario the text provides. You are in a public place. You see someone who is heavily bloated in the abdomen. They are panting forcefully through their chest and they suddenly collapse. They are losing consciousness.
Okay.
The immediate modern reflex, especially if they are a known diabetic, is to scream for a glucose monitor. Check their sugar.
Right, but the author states unequivocally,
Yeah.
forget the glucose monitor, do not look for a digital explanation for a mechanical failure.
A mechanical failure.
Based on the individual's bloated abdomen and chest panting, the text diagnoses the collapse as a mechanical failure of venous return. The chest pressure spiked so high that blood simply stopped reaching the brain.
The brain powered down to say itself. So what is the mechanical intervention?
It is entirely physical. You lay the person flat on their back, you elevate their legs significantly above the level of their heart.
You are using gravity to do the work the heart currently can't. You are forcing all that pooled blood out of the legs, past the compressed abdomen, and dumping it straight back into the chest and brain.
Exactly. You manually restore cerebral perfusion.
Wow.
But the text adds a really critical safety caveat.
Yeah.
You must turn their head or body slightly to the side.
To prevent choking.
Yeah. Because of the intense intra-abdominal pressure, or maybe because they consumed a highly incompatible, indigestible meal, there is a high risk of vomiting as the body tries to forcefully and rapidly decompress the stomach.
The source makes a really fascinating, somewhat dark clarification here. In clinical settings, if a diabetic patient vomits, doctors often blame it on the high levels of acetone in the blood. They say the ketones are making them nauseous.
And the author flatly rejects this.
Entirely.
The text insists acetone does not cause vomiting. The physical crushing pressure of the bloated abdomen against the stomach or a massive load of putrefying food is what triggers the vomiting.
It is a profound example of misattributing symptoms. If you blame the acetone, you try to chemically fix the acetone. If you realize it's a mechanical pressure issue, you fix the posture and the diet.
And this misattribution becomes exponentially more dangerous, according to the author, when we apply these digital interventions to children.
Oh, this part was heavy. The text issues a severe warning regarding pediatric endocrinology. It is incredibly critical of the rising trend of diagnosing children with prediabetes or insulin resistance simply based on a blood test.
The author argues that introducing exogenous insulin or blood sugar-lowering pharmaceuticals into a child whose endocrine system is still in the fragile stages of development is a catastrophic error.
Why specifically?
Because by artificially forcing the blood sugar down, you are actively starving the developing brain and suppressing the natural maturation of the entire glandular system.
I really struggled with the downstream effects the text listed here because they seem so disparate. The source claims this early medical intervention leads to stunted physical growth, which makes sense if you are starving the cells. It mentions thyroid malfunction.
Right.
But then it claims it causes polycystic ovary syndrome, PCOS in girls, weak sperm production in boys, and chronic unbreakable candida yeast infections. I mean, how does a blood sugar drug cause a fungal infection?
Comes back to the adrenal glands again. If the body is trying to mount a stress response to clear a toxin or fight an infection, the brain commands the adrenals to raise blood sugar to fuel the immune system.
Okay, that tracks.
If a drug constantly blunts that blood sugar response, the adrenal glands are kept in a state of chronic suppression and exhaustion.
The immune system's battery is permanently drained.
Yes. The natural defense mechanisms are chemically sterilized. Opportunistic pathogens like candida thrive in that immunosuppressed environment.
Wow.
The text notes that attempting to treat these recurrent yeast infections with local topical washes, antiseptics, or standard antibiotics is utterly useless. You're treating a local symptom while the root cause, the chemically suppressed adrenal system, remains completely ignored.
So if the body's natural processes, the sugar spikes, the acetone, the hormonal surges, are all desperate attempts to save us, and the drugs are merely getting in the way of that rescue mission, what is the actual enemy? Why are the mitochondria struggling so hard in the first place?
The author points a massive, uncompromising finger at the modern environment. The true pathology, the root cause of the metabolic collapse, is an unprecedented environmental toxic load that completely overwhelms the liver's detoxification pathways.
We're talking about the agricultural and pharmaceutical environments. The text lists pervasive agricultural pesticides, chemical fertilizers that destroy the soil microbiome, global wheat supplies that are deeply contaminated with toxic fungal spores, and poultry injected with synthetic hormones.
It's a lot.
But the most striking critique is leveled at our over-reliance on pharmaceutical antibiotics.
Yeah, the text highlights a fundamental irony regarding antibiotics. Many of our most common antibiotics are literally derived from mold. They are mycotoxins.
So a patient feels sick because their immune system is overwhelmed by environmental toxins, and the medical solution is to ingest a highly concentrated fungal derivative to, quote-unquote, cure them.
And the mechanism of action is what matters here. These fungal derivatives, these mycotoxins, actively poison the mitochondrial respiratory chain.
Like they shut down the factory?
They disrupt the electron transport chain within the hepatic mitochondria. The elite off-grid power plant we discussed in Section 1 is suddenly forced to abandon its primary job of clean energy production. It has to dedicate all its cellular resources to detoxifying and surviving the mycotoxin you just swallowed.
The mitochondria are too busy fighting off the poison to efficiently manage the gluconeogenesis, or the ketogenesis. The factory floor is in absolute chaos. So how does the author suggest we navigate this highly toxic minefield? The text shares some of the author's deeply personal and quite radical dietary adaptations designed to bypass this toxic load.
The strategies are intensely specific and focused on harm reduction. For example, the author explicitly avoids standard mass-produced potatoes due to their high concentration of agricultural chemicals.
What do they eat instead?
They opt instead for specific, pre-processed farm frites, presumably because the specific processing method or origin soil bypasses the local toxic supply chain. The author consumes shawarma, but strictly eliminates added sugars. There is a heavy avoidance of commercial meat, viewing it as fundamentally poisoned by the hormone and antibiotic injections used in modern agriculture.
But the most fascinating practical adaptation the author uses involves white vinegar. Why white vinegar?
Standard white vinegar contains roughly 7% acetic acid.
Let's connect the biochemical dots here. Earlier, we established that the liver takes even-chain fatty acids from body fat and turns them into acetone. Acetone is chemically related to acetic acid.
Precisely. The author is utilizing a physiological shortcut. By consuming white vinegar, the author provides the peripheral tissues with a direct, exogenous source of an organic acid.
So it bypasses the liver's processing line entirely.
Yes. This acetic acid can temporarily stand in as an acetyl group donor for cellular metabolism. It is a clean-burning fuel that provides immediate energy without requiring the liver's mitochondria to perform the heavy metabolic lifting of breaking down heavily poisoned dietary fats.
It's a biohack to give the liver a day off. Synthesizing all of this, the ultimate practical goal of the source material is about unburdening the system. You want to reduce the incoming toxic load, fix your mechanical posture so you can breathe deeply and allow blood to circulate, and stop chemically suppressing the liver when it's just trying to keep you alive.
The philosophy demands that we stop treating the body's compensatory survival mechanisms as if they are invading diseases.
This has been an incredibly dense, paradigm-shifting journey through this text. Let's recap the core architecture of what we've unpacked today. We started by completely reframing the very presence of high blood sugar and acetone. Far from being the ultimate signs of metabolic failure, the source argues they are the hallmarks of a healthy, functioning liver fighting desperately to keep a stressed organism alive.
We explored how the brain, sensing a crisis of circulation or toxicity, commands a massive symphony of hormones, cortisol, adrenaline, growth hormone, to orchestrate this sugar dump.
Right.
We examine the controversial claim that blindly suppressing this natural response with exogenous insulin, merely to satisfy a digital metric on a lab report, fundamentally starves the cells and leads to chronic organ deterioration.
And we brought it back to the physical mechanics of the body. We looked at how something as seemingly healthy as a rigid six-pack can mechanically strangle your venous return, forcing your chest to heave, starving your brain of oxygen, and throwing your entire endocrine system into a state of chronic panic. It all comes back to recognizing the physical realities of the human machine, rather than obsessing over the data points.
The source challenges you to view the body as a highly intelligent, self-regulating ecosystem. When symptoms arise, the goal is not to silence them, but to address the root mechanical or toxic stressors, the restricted breathing, the mycotoxins, the poor circulation that are forcing the body into emergency mode.
I want to leave you with a final, incredibly provocative thought straight from the author's core philosophy. The text boldly claims, "No study on Earth has ever proven sugar is a poison, nor found the root cause of essential hypertension. They only treat the numbers."
It's a heavy thought.
So, I offer you this challenge. Next time you feel that crushing chronic fatigue, the next time your mouth is unquenchably dry or you feel dizzy standing up, instead of immediately asking, "What is my digital number?" ask yourself, "What is my body desperately trying to defend me against?" Are you going to continue putting your blind faith in the digital readout of a machine, or are you going to start trusting the profound biological machinery you were born with?
It is a question that requires a complete dismantling of how we currently view our own physiology.
Thank you for joining us on this intense and thought-provoking deep dive. We'll catch you next time.